In this problem, we are asked to identify the lines of reflection or lines of symmetry for the square that is graphed in the coordinate plane. We know that a square has 4 lines of reflectional symmetry. It has a line of symmetry connecting the midpoint at one side to the midpoint of the opposite side. We can verify this is the midpoint by counting 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So from this midpoint to the midpoint on the bottom, so this line that I'm doing in yellow highlighter is one line of symmetry. That line is the y-axis, which has the equation x equals 0. All right, now we could do the same thing, connecting the midpoint of the opposite sides going horizontally. So let's look at that. So that's going to be on the x-axis. And again, we could verify that this is the midpoint by counting 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So these are the midpoints. Okay, so this is the x-axis, which is a line of symmetry, or the equation y equals 0. Okay, now a square also has lines of symmetry that are diagonal connecting the opposite vertices. So let's go ahead and connect our opposite vertices. So we have this vertex to this vertex. It's going to pass through the center right here. And that is the equation y equals x. So if we look at that line, it has a slope of 1 over 1. And it passes through the origin, so y equals x. Okay, now let's take a look at our other set of opposite vertices. We'll go this way and pass through the origin. Okay, so this is the equation y equals negative x because it has a slope of down 1, right 1, down 1, right 1, so negative 1, and it passes through the origin. So these are the equations, x equals 0, y equals 0, y equals x, and y equals negative x for the lines of reflectional symmetry for this square.